Um, did the bell go? Okay. Okay, we're gonna get started. Here, Dr. Wang, you come up later. Okay. We're gonna run this session a little bit different. We have two presenters, and then after our presenters, we are gonna have a fireside chat. So, good morning. It really feels like afternoon for me. As stated, I'm Dr. Elizabeth Cook. For the next 90 minutes, we're going to talk about AI in the power systems. And I guess I want to just start by narrowing it because this topic is big enough that we can go in many directions. So it's really about talking and explaining where AI currently exists in power systems analyses in our current industry space. So we're going to have two presenters. First, Dr. Xing, and then Seong. Thank you. They're going to go back to back, and then we're going to bring up the other four panelists to continue the conversation. So with that, Dr. Xing.
Good morning, everyone. So my name is Xing Wang. I'm with AWS, Amazon Web Services, Energy and Utility Business Unit. So I lead our grid modernization business development globally. So I came from the industry. I've been with AWS for 4.5 years now. I joined AWS from Centrica in UK. The brand is British Gas. And I was there for 5 years, and before that, I was with Alstom, later GE. So my last role over there was manage the control room solutions such as EMS, market management systems, and ADMS. So today I'm going to spend maybe 15 minutes to talk a little bit about what we see AI evolution, how AI has been leveraged by power utility industry. And I'm going to use a couple of examples. One is specific interconnection automation to demonstrate how agentic AI is transforming the business process. And I then will introduce the quote-unquote control room of the future topic, and then hand it over to Seong for him to dive deeper into that topic. So we all know that AI is not new for our industry, right? We've been using different form of AI for our planning, forecasting, planning, business operations. Right, started from a traditional form of AI, like machine learning, and then like 3 years ago, right? So this large language model became really mainstream, and then everyone started to use chatbots, right, powered by large language model. So early last year, we see this transformation. I really think that is the transformation from generative AI to agentic AI, mainly because for our industry, we want AI to solve business problems. We don't want AI to just check our emails and summarize the meeting notes, right? That's just the beginning. But we really want AI to help us solve business problems. And we see a lot of autonomous agents being developed. And the major use case over there, you would agree, that is software development industry. We see a lot of like cloud code and other agents will help us help our development team to be much more efficient. Moving forward, later this year, I think we'll see more development or progress on physical AI, right? Combine physical world and AI, robotics, and this is also very important for our industry moving forward. But it's right now a little bit early stage. A lot of acronyms in AI, just like a power system. We love acronyms. A lot of those you probably know already, large language model. But I like this human analogy that is actually created by one of my colleagues. So the large language model is still very important. It's like a brain, right? So the key thing we want to focus is the reasoning capability, how smart you are. It's not like how much knowledge already built into the large language model. We're not going to leverage that because hallucination and all that reasons. So really what we're trying to use for the large language model is the language capability, understand what we want it to do, and reasoning capability. Then we get retrieval augmented generation. It's almost like you connect the model to trustworthy information, right? So if you want your AI agent to answer questions, it needs to be based on trustworthy knowledge base, not through the memories of the large language model. And the third thing is the agent. And then last one is very important. I'm sure you heard about this MCP, Model Context Protocol, was actually initiated by Anthropic a couple of years ago. And this is very important because that MCP layer really enable the large language model to get connected to our existing tools, right? Like power flow tools, like contingent analysis. And then we can use that reasoning capability, very, very strong, even at PhD level, right? To utilize the existing tools based on your data to perform the task we wanted to do. Many use cases, right? One key message here, I'm not going to go through everything, but one key message here, even though we're talking about generative AI, or leverage machine learning, the expert system, everything we built so far stay very important, very, very valuable. Our existing tools, those physics-based formulations, tools, remain to be very critical. They are not going to be replaced by Agentic or generative AI. They're going to be enhanced by those tools. I give you an example, demand forecast, right? You know, we continue to use linear regression, for example, in very short term, 5 minutes, hour ahead, load forecast in our operations. It's still one of the most promising algorithms out there. Later, we have neural network-based algorithm we can have demand forecast. Now, at Amazon, we developed a large language forecast. And that doesn't replace all these existing methods, right? So going back to the agent, it's very important, like I mentioned. So you have your choice of frontier large language models. Brain. Pick the right brain, which you trust, right? Is pretty smart. Leveraging your existing tools. Focusing on challenging business problems or process where you have very many process, error prone, right? You don't have enough resource, especially those domain experts to work on that. Pick those challenges, leveraging AI in your environment, using your own data, existing tool, automate the process. And I list a few examples that we're currently working on with our utility partners. And I want to dive into the interconnection automation. I'm sure everyone here, yesterday we talked about large load interconnection. I mean, everyone is aware of this challenge, right? It's real. And we've been asked to help. And if I oversimplify the process, right, from either generation connection or large loading connection, you got application coming in, right? The engineer will review the applications and then put the models, either large load models or generators, into a grid model, generate a lot of scenarios, doing system impact study, either in cluster or individually, right? And figure out the violations, figure out the grid issues and enhancement and price it, right? And send it back to developers. If developer is not happy, withdraw, they have to do it again. That is why this is not the only challenge, right? But the system impact study is one of the major challenges that is require a lot of our engineers to do, and we only have finite number of experts which can do this. So what we have done is certainly We did quite a bit engineering automation, right? To automate some of the processes, like model build processes or study prep processes. We are currently working on agentic systems to further optimize and streamline, automate some of the process, such as power flow studies. And very soon, I want to show you a very quick example on how the power flow can be automated. Power flow study can be automated with agentic AI. This is the work that we started with Duke Energy. And the first phase was study preparation. This is with their generation interconnection team for transmission level. That process used to take 30 days. We reduced that to 45 minutes through automation. That's in production today at Duke Energy. The second phase is what I'm going to show you. This is an early stage demo. We are predict to go production in August. This is to help automate the power flow studies. And I want to emphasize, this is the principle here is planners are in the lead. They're not just in the loop. They are in the lead for making decisions. AI is in the loop. Okay, AI is everywhere trying to help planners to reduce the manual errors and optimize some of the steps. And the whole process is physics grounded. So meaning we have to validate the result using existing power flow engine before we present it to the planners. So I'm going to show you a very quick demo. So the first thing you can do is we allow the planners to put in business rules. How are they going to dispatch generators? How they typically address voltage problems, right? This is human language rules, either a document or something. And then we can do some studies. For example, if we say add a large load somewhere, the agent, the preparation agent will add the load into the model and then start to calling the solver to solve the power flow. It's a simulation agent. And then you can see it start to present some issues after they solving the problem. There's a voltage issue, and then even further, it based on what you learn from the planner, it presents the options to solve those challenges. And it's up to the planner to decide which option it will take. Or it may be a better option. You think that tool didn't present, it will provide the feedback, and next time the tool will, the agent will learn from that, right? And you can see this is a pretty much interactive process between the agent, multiple agents. It's actually up to 12 agents over here to coordinately helping the planners to do this job. And after that, certainly will automatically generate the reports with all the details, and all of these are validated with their existing planning tools. And that is very important. I know moving forward, we're going to have domain foundation models. We're going to have different ways to solve the problem. But as previous panelists mentioned, the adoption of the new tools, new models in this industry is quite slow. So how to get them, make the planners feel more comfortable adopting this innovation is to leveraging existing tools that they're familiar with and based on existing data. We're not changing anything. We're just making things faster for you. And if you can see that everything is documented, everything can be audited. This is also a great way to train new engineers. Think about new guys coming in, doesn't understand Duke system. They can look at this, trying to solve this problem with agent and help them understand how to address those problems. So that's another side benefit, if you like. Oops, sorry. Okay, with that, last two slides. Everyone is very concerned about control room environment. Me too, right? I used to provide the control room solutions for many companies and ISOs. But when Gartner actually did a survey, I don't know if you're aware of this, with many utility executives, they all predict AI adoption in control room will be critical and will be almost 40%. I forgot the actual percent, 40%, yeah, will adopt that. Why is that? I mean, we can argue what percentage, how fast, but that just shows the real value of AI tools is for grid operations, right? So that I think we can, if we can use that in a responsible, reliable, and secure way. And the last slide, so I'm not going to go deep. I draw this one based on my previous experience. I will let Seong to talk about this. But fundamentally, here we're talking about, today we have individual system, EMS, WAMs, markets working well, right? But they talk to each other as well to a certain degree. But we still don't have a fundamental comprehensive model for our grid. And to solve look-ahead studies, like, for example, a storm going to hit your part of your transmission grid in 2 hours. It's a hustle to set up all the cases, right? To do that, run that, present result. And all that, I think, can be really addressed with the high-performance computing and AI agents combining like physics-informed results and also the ground truth from the manuals and documents. With that, I'll hand it to Seong.
Thank you, Seong. Very impressive demo. Yeah. So Seong shows the applications in the control room. The one that I'm going to talk is why control room? And maybe you want to see this video that I created earlier this morning. The video shows why control room. Control room is the brain of the grid. And that's where you have a forecast coming up, you schedule unit, and you dispatch. Right? And that's where they're doing tug of war between generation and demand through the transmission operator. They need to figure out where to and where from and which line to maintain 60 hertz, 120 volts, and has to be economy, right? Those are the reliability and the stability and affordability and resiliency. The next one I'm going to show is why I was interested in AI. So this is back in 2023, right after ChatGPT announced. And I asked, hey, can you write a code for me for Pi Historian? I was really surprised. And I verified it worked. And it was in the cloud. And I know NERC would not, or utility would not allow anything in the cloud. And so starting then, I worked on the local version solution that you will see that this is all local. As you see on the bottom is the airplane mode, and it's running code for me. And I worked in the peak. I didn't know the Ryan back then, but the Ryan worked in the peak. The operator, when they ask for something, they ask me, hey, Seong, can you write up this? It will take weeks or months to come up something. Now, with AI on my local, now I don't have to worry about token sizes and all those if I have enough GPU. Not like Seong, he has tons of GPUs. But if I have good amount of resources, then I can I can use my tool to write the code for me, maybe within a couple of minutes. What you can do with this? This is where we see at the national lab we see that the future of the control room is basically start with the assisting operator. And in this case, there was a hurricane alarm in the Texas area. And so operator asked, hey, what's the impact to this alarm, to the system? How many lines will be impacted? What is the load shed will be, and what will be the mitigation? Because of, I worked in the utilities, I know it has to be explainable. It has to be transparent. Again, on your bottom is still airplane mode. I'm not using ChatGPT for that. And then as Seong shows a really good demo, we are using the same protocol MCP to run the power flow analysis. In our case, I use a Power Word to run, automate the whole process. And once you have all of them automated, then you have the report. Then the one that utilities ask me every time I ask what use cases they want to see is alarm or information overloading. Too many alarms. And main reason is because of the one event could cause 1,000 same alarms coming in. So how to aggregate impact the current operation. I think that was the main reason we started AI project, thanks to Department of Energy, that we have a funding and we have utilities is able to show, able to give us all the feedback. So if you have if you want to be joined, let us know. So at the national lab, it's a national lab, right? We don't have all the bells and whistles. However, luckily, thanks to PIC-RC and WAPA, we have NDA signed historical data, 5 years of historical data, 5-minute snapshot, about 14 terabyte we have to train. And also we have a real-time EMS system, the licensed GE. And we have 2 campuses in the Flatiron and then the South Table Mountain. In the both campuses has a transmission and distribution test bed. So it's not just a simulation. We actually connect to test bed. And that's how we make sure the result has to be accurate. Without the target we are going after is a 95% accuracy. So accurate, the result has to be physics informed. And then AI must assist operator. As Seong said, human in the loop, but human has to be driver seat. If someone asks me to, hey, I called the Uber and it says, you want Waymo or you want to have a driver? I always reject Waymo. I still don't trust Waymo yet. I don't expect that type of the full automation in the control room. So the AI has to assist the operator. And as Seong mentioned, the automation is a really cool, the high demand because of the taking so many hours or months. The one that I heard from the PJM case was their interconnection queue was years, but now down to 18 months, thanks to their AI support. And the fourth one, to augment the data. I mean, we are talking SCADA, but now we are getting to PMU data and also all the DR edge devices data. Operators don't have time to process all of them. And then weather and the other information. So why don't we leverage AI to do it? And it has to be aligned with the stakeholders, the operators, what they're looking for, the trust, the response has to be right and can be trusted. And also it must be no compliance. And also, stakeholders main benefit, safety, right? So we at the national lab, we are with all those 5 goals, we are writing the AI applications. The next one is, so now I talked about why control room I was interested in and what use cases we are working on it. The next question is, even if AI is good, are we ready to actually adopt it? So I listed 3 categories. One, from the industry-wide. First, the software that the operators using is CPU-based, is sequential-based. That's true, right? Because of the old operation has to be sequential. If overcurrent relay trip, right? This has to be sequential. But when we process data, we don't process I first, year second, and the nodes third, right? We process them all. If you have so many data, it has to be parallel processing, not just data, but the power flow. If you have a small number of buses, yes, you can do it. But what if it's a whole the corners, the nation grid? It has to be parallel processing it. Second, the data that utility collect is not for AI. Why we collect the data? Because of operation, because of the audit, not for AI training. So it's not ready for training, ready for AI training yet. The last one, GPU. The cost of the GPU is prohibitive. No one can, I don't think anyone can actually, from the utility side, buy what the AWS has, right? So how to make the reasonable size of GPU so they can host their solution in their data on-premise and run with it. The next one is, again, the accuracy, the hallucination. I checked the ChatGPT and Google Gemini. They improved a lot, but still it's not there yet. The main reason is the utility don't share data. Without the data set, there's not easy way to train the actual system. The last one is adaptability. I mentioned the Waymo or versus Uber, right? And so this is where that the utility is, it will take time. Lastly, utilities is a highly reliable organization. The meaning, even if the technology is so good, they don't simply accept it. Didi mentioned, you have a good benefit, but there's a risk. And so we have to think about it, how the technology will be play out when we adopt, it will impact the reliability. The second one, again, the NERC ships. Without the cloud solution, right? The reason that we don't go to cloud is because you don't know what's coming in and going out, right? And so how do we maintain the resiliency by respecting the NERC ships? The last one is, who will approve the AI? Meaning NERC system operator, they have to go through the exam. They have to go through the certification process. Will AI go through the same process every 3 years? That's the questions the organization must answer. The last, at the national lab, we are thinking in the future, not 5 years later, maybe 10 years later. This is what we are thinking, that in the humanoid robot and also virtual reality and augmented reality will help operator. They give them the situational awareness and also transmission overview and the distribution and the later virtual power plant and the DR, the aggregator. Main reason is because of inverter resources, inverter-based resources is impacting from behind the meter to transmission. So we need to see all aspects of the utility side. That's it for me. Thank you.
Okay, I'm gonna sit. Is that okay? Well, thank you. Um, that was very insightful and informative. And so before we kick off the fireside chat, just a little background of myself. I currently am the Vice President of Technical Strategy for Associated as an Illuminating Companies. I've been a part of this organization originally as a utility member, where I was the Senior Manager of Transmission and Distribution Planning at the local utility that I was born and raised, Pittsburgh, Pennsylvania. And as an AEIC member, I attended our cohorts, our committee sessions around distributed energy resources. And I also worked on my doctorate with Dr. Wang, really using the data to gather insights, but really build models from something that we didn't have to something that we do have. And so really I created a passion around, what can data do to really enhance the utilities operation. So 2 years ago, I came into, I guess 2.5 years ago, came into AIC, where I have this awesome opportunity to meet with about, well, I'm counting, I'm immersed in some data myself in regards to the engagement at AIC, but there's multiple committees and I get to talk and communicate and really learn, where is your data? How are you using it from system planning, asset management, engineering, control center, field ops? And of course, as you all know, and probably the reason why we're all here, is AI is a large buzzword. And when we break it down, artificial intelligence, what does it mean and how can we incorporate it now? And so as we just saw, there is many opportunities to tap into the use cases for utilities to really launch into it. So I won't belabor the idea that having access to the data, trusting the data, and then being able to build upon that is one of the greatest feats I think the utilities are faced right now in regards to gaining that trust that we're all going to talk about today. And really from your perspective, so we have 4 unique perspectives in regards to how to build this trust of this terminology AI within really all of aspects of kind of how the grid and the grid external stakeholders proceed. So we have Ryan from NERC, Didi from Kyoso, we have Mohammed from CLECO, and we have Dr. Wang from Arizona State University, each providing a unique perspective of how AI is being introduced into the power systems and really where is this bridging that's needed. So I lied. I told you I was going to give you the baked questions, but I actually have a question for you, Ryan. We'll start off. So Ryan from NERC, before you start talking, introduce yourself to everyone. But the question is, the white paper that I guess was issued end of 2024. There's a lot there. And then really there's a new one coming out because it's almost outdated. So I'll let you explain that a little bit. But really just kind of share the thrust of like what that white paper is and what was it saying in regards to, the trust in the control room and where does this all come into?
Yeah, hi everyone. My name is Ryan Patton. I do work for NERC. I was a reliability coordinator in the West for about 13 years before joining NERC. So I used to work with Didi. So it's great to be up here with Didi today. Being a reliability coordinator in the West, I've seen a lot of operational changes over the last 13, 14 years. I was on shift when we got rid of the TOP 007 standard for path operations and the use of RTCA instead of the old path paradigm. So I've seen a lot of change, but that change came with a lot of operator trust. So as was mentioned, the NERC white paper on artificial intelligence, I think from an operator perspective, one thing that they get hung up on a lot is that first word, artificial. When you have a human in the control room, it truly is a human making a decision. The tools that they have are truly their tools. They're trusted, they're verified, you can replicate them, they're redundant, they're secure from a cyber physical perspective. And I think that's what the white paper really focuses on is that human performance and making sure that a human in the end is making that final determination regardless of what that tool says. I worked with an operator who said, I don't like the terrible twos when it comes to NERC standards. So that's like the COM2, BAL2, EOP2. COM2 is one of the most violated standards because in the end, when we come down to that final communication, we want it to be clear, concise, and in 3-part. so that we truly understand what we're going to say. So operators are always well trained in the end that if I heard you wrong, I make you repeat it. And I think a machine-to-machine interaction can be difficult in that world. So in the end, I think that white paper truly says that we want a human involved, but it doesn't mean that we don't want AI to maybe enhance or provide some guidance.
With 21 directors of the operations center last fall, and it was full circle 2.5 days where they were sharing their journey, their story, where they're building out the systems to really unlock and enable a lot of this AI advanced kind of capability. And at the end of the session, there was like a round table of like, what do you want the control room of the future to look like? And it fundamentally was like they all just want one screen with the key data points to not overwhelm their system when making a decision. So, this control room right here with your 4 key points. But it's important that that individual human, that's what they all shared, is that they can trust the processes that are running in the background to be able to make that ultimate in the human loop decision. So does that look like your control?
As a previous system operator, anytime a new tool got released, we challenged it. We beat it apart. We found all the flaws in it the best we could. And I think that is not going to change, but the future is bright. And I think change is also good as long as we do it correctly.
Right, change management. So Dee, I'm going to put you on the spot. From our previous discussions, you have AI currently today pointed at 2 problems, and kind of what we've discussed, and a lot of us discussed, we're really start thinking about the tool before the actual problem. So we get lost in like, what are we actually trying to solve sometimes? So, you want to speak to the 2 problems that you're solving with AI in your control room?
Sure. This is Bhakti with California ISOs. Currently of AI in California ISOs, aside from all the neural network, data forecasting, cybersecurity, all those other stuff, that's been there a while. But the journey to actually get into the control room operations started with this whole discussions about, honestly, it's because everybody's asking, what are you doing with AI?
What came first?
We it's a buzzword. So we sit around our executive and our VPs and everybody, and we're like, well, the board asks what we are doing with AI, and we're like, I don't know what we're doing with AI. So I personally start asking the question, is this a solution looking for a problem? Right? This is 2 years ago. This is solutions looking for a problem. And then me and the vice president of technology start putting our head together, and we're basically, look, if we're going to put something in the operators, I think I mentioned this earlier today, that we should not shove down a solution to the operators. They will never like it. They will never use it. And I remember that we built a very good tool, spent millions and millions of dollars, and the operator really basically did not want to use it. And we shut down that project because the operator didn't want to use it. And we spent millions of dollars on it. And so we start with this backward a little bit. Well, I think I looked at it forward, but they're thinking about backward. So we actually had operators and engineers in one room and says, what is it about your job that you do not like? And very quickly you get a list of the things that they don't like, right? And it's actually become too many. And then you have to like prioritize it. One item was actually very simple, and it's this whole notions about we have so much data that we came in and they want everything. And they says, no, that's too expensive. Let's find something that we can do for free. So it basically says, okay, we process about 20,000 maintenance requests. I'm talking about outage requests, but 20,000 maintenance requests a year So roughly about 2,000 per month. And we really actually just want to know if we could have a summary of a report, because I don't know which one is important, which one that is not important. And Ryan's probably were part of those people that just hated building that report every day and trying to figure out what is actually important, not important. So we asked the question of very simple things. Okay, we have a vendor that already have our OMS data, our outage management data, and it has all this data. It's a cloud-based and it's there. And what if we, we have a machine learning, all the data, we put a rack. I think everybody now know rack because we already talked about rack, right? We put a rack on that and it with multiple agents in there. And then people can actually just do conversations rather than looking at and building report. It's that's actually the first aha moment. It's like, why do I want to build a report? And because every time we want to build a report, the vendor is going to charge at least $20,000 just to build a report. So we said, let's just create a chatbot on that. And then when we start doing that, we said, okay, that's kind of cool. And then we said, well, what else do we want to know? Oh, when we have maintenance and all this stuff, it always connects to our operating procedures, our operating guides. Well, okay, let's feed that operating procedures and operating guide into the rack. So now you could actually have that conversations about a particular outage or particular maintenance or everything. So the key there is that the operators and the engineers define the solution, they define the problem that they want to get solved, and they were part in that use case development and everything that's in there. So that's one item. We get through another portions and we specifically talk about to the RCs, and we ask the RCs, so what is your biggest problem that they don't like surprises, and they always say that, well, I get the surprises where we get into the day, we have 2:00 morning call with everybody? Yeah, 2:00 morning call with everybody. And then everybody says that we're going to be good. There's not going to be any problem. And then 6 a.m., 7 a.m., and then you get an energy emergency alert. And then they says like, how did that happen? Okay, well, because everybody don't have good data and all this other stuff. So that we say is that, well, there's a lot of data out there. Why don't we put an AI and machine learning? We put a rack, and now this particular rack and agent actually have access to some of the proprietary or confidential data for generation outage that we have, but we also put a lot of publicly available data from Oasis, from weather, to actually create the predictions on how likely somebody's going to be energy deficient. So those are the two examples, and we'll talk a little bit more about it if you have any questions later.
Love it. So outage management and capacity planning, you were able to unlock. And I guess, just sharing, one of the activities that AEIC is participating in is the data framework group. And so I had the privilege of running these workshops for 2 years, and it was really about this idea of integrated system planning and operations. I had some intention prior to launching these workshops, but I really wanted to find the core themes of what was preventing the discussions of integrating planning with operations, and what data sets were being asked of and asked for, and how can we make them accessible. So talking across all of the groups within a utility, it was a common theme of not having ultimately 4 items, which have been baked out to be true, and I just heard them in your conversation, is, the first ability for utilities to unlock these new ways is executive alignment. So having the leadership from the top down to really be behind and give the coverage to the individual spirited folk that are going to drive this change. And then the second one is giving those beings, those practitioners, a sandbox of where to place that data. So you were speaking to the idea of, you had the outage management data in the cloud, you had this data, you had that data. So that was the other one, is giving those folk access to said data without the language of it's dirty or incomplete. Just understand it is what it is and use it for what it is at that moment. The third one that was a constant theme is the partnership and the language between the operation leaders and the IT leaders, and them being understanding of each other, knowing that the the vernacular that they both hold is not wrong, but may not communicate effectively across. And then the fourth one was really just get started. So I'm going to tee you up, Mohammed. We met ultimately because he heard through the grapevine that this conversation was happening. And my former role in the utility, I was the director of grid mod, and I became aware of this thing called change management. And it wasn't the technology, it wasn't the AI, it wasn't the capability. It truly became the processes for which we are touching and the people that operate or monitor or drive said process. And that just became a whole other level. So you have a special flavor in that space, Mohammed, and that's how we met. My question to you is, you've also studied this idea of distrust amongst entities, and really what actually moves that skeptical practitioner operator, and what makes it worse and what can make it better.
Yep.
And also, don't forget to introduce yourself because Dee already introduced himself earlier.
Yep. I'm Mohammed Garaibi. I'm the manager of AI and digital transformation at Clico. Clico is a power utility company in Louisiana. We're a small size company. We have about 1,300 employees. So I'm going to speak about our journey at Clico with data and AI. We started and I established the department back in 2018. The CEO of the company wanted to become more data driven, even though we've been using data. We've had regression models, we've had some machine learning models that we didn't call them machine learning models at that time. So we started using those more fancy terms with time. So in 2018, we started looking at some visualization tools. We started using Tableau, implemented Tableau. We started the first phase of bringing trust in the data and get the help from the business to clean the data so we're able to get insights from the data. So we started building some dashboards first. Before building the dashboards, myself and my team, we embedded ourselves in the business process. We understood what the business was doing before we started building the technology. So we started with the problem, and then we came back, we sat, and we thought how we can solve the problem with the technology. First thing we've seen at that time was vegetation management. They've had a regression model, scored the different circuits around the grid and our service territory. We looked at that model, we enhanced it, we built some visualization with that model. The business started looking at it and asking questions about their data. So then they started trying to enhance and clean their data. So it became their responsibility, not our responsibility, because they wanted to make sure, yes, we see a value on these visualizations and these enhanced machine learning models. And then we thought about how can we start this initiative, with established structure and foundation. We've had several conversations with the compliance team, and then we decided to go on the cloud. So we implemented Databricks back in 2020. At that time, it was only built for the data science team. No one else was allowed to be on that environment. So it was for us to build some POCs. In the previous panel, they were talking about POCs and pilots. So we started doing POCs back in 2020. And us, the data and AI team, evaluate the outcome of these models before presenting that to the business. So we understood the problem and we tried ourselves to come up with a solution of the problem in this secured, locked environment. After that, we started to look at who we can bring to this environment. We started working on some governance to make this environment more secured, and we established a program we call the AI champions. Those AI champions, they were selected by their leadership from every single department in the business. We have about 33 people or employees that we call them AI champions. And we started that program not too long ago. So enough to adopt technology, or they're not quickly going to adopt the technology. So we're trying to move slowly, but with full adoption. And then when we started bringing those AI champions to the Databricks environment, which Databricks is, for whoever doesn't know what Databricks is data analytics platform, for coding, for building applications. And we've decided to use that platform back in 2020 for so many reasons, but there's some other alternatives. It's not just the only solution in the market. So I'm not making the sales pitch for them. They don't pay me anything. So
But it's a big question that has to be identified and determined as a pathway.
In 2023, when they released the first open public LLM model, which, by the way, it existed before. I went to a Gartner conference back in 2021 and 2019, and they were showing us, and we started using those LLMs, but they were not as good as what we have today. So yeah, and then with those AI champions, we started thinking like we need to enable the business, spread those capabilities. And now with AI, it's easier for them to build their own analytics, their own AI chatbots. So right now, we have this group of people that are building different applications to I look at them as our sales marketing people in these groups, and that's how we brought adoption to AI within our company. And there's no right answer, but it worked for us because we were taking slow steps and not making huge investments.
Right.
The department back in 2018, I said department, it was just me. But then now we have 9 people in the department, 3 for the AI and the rest for the data science.
Thank you. So we're gonna tee it over to kind of Dr. Wang, and I just have to share another backstory. It was 2017, so this was before AI really became a buzzword for us. And I was working in system planning, and I was currently the transmission planning manager. And I know that we were rolling out AMI at the time, and we did not have a distribution model. And I also noticed as a transmission planning manager, there was a lot of projects that were being trickled to a transmission expansion based on a distribution type problem. So I started asking a whole lot of questions around the distribution and identified we didn't have those models yet, which was actually middle of the road just 10 years ago. The likelihood of all electric distribution companies having a full fleet of distribution models in 2017 was like maybe 10%. So, just thinking about that transition of now we're trying to run AI on distribution models that were just being developed as like a static visual. But anyway, I ultimately had an intern who moved to Arizona, and he read a research paper by Dr. Wang and said that the AMI data could be used to study the voltage correlation to understand the secondary connectivity from the homes to the transformer. And that was when I decided that was going to be my research for the next several years. And from our relationship, I think one thing you asked is like, well, we need the data. I was like, okay, I'm a senior manager of a utility. I'll go get that data. And boy, did my life change. I learned it wasn't one person I asked, it was 25 people. And everyone wanted to know why. And no one believed that I could do something based on what we were saying we could do. So my world of becoming a change champion, or a AI champion, as you just called it, was deemed, I knighted myself, I suppose. And the amount of pushback that I received with positive intent on giving access to this data was enormous. And so when I think about, all of the industry looking at the utilities saying, well, why can't they get started? Or can we just have the data? Or why don't you just share all the data? There's so much complexity of where this data sit. And this was just AMI data. And the first thing I learned is our highway from which the communications that we built out and made a decision on 10 years prior, was not large enough to bring this enormous amount of data back and to just deliver it to some snazzy lady who wants some data to run a model to say, hey, here's your distribution model built. Maybe we don't have to do the $80 million project that we're actively in flight. But anyway, so Dr. Wang, you taught me that, there is a way and there is possibility, and just to keep asking. But tying it to the trust of AI, who knows where you're sitting now 6 years later with the tools that are available to your students. But, tying it, utilities don't truly need AI. We need to understand the physicality and the current utilization of the grid, so the physics of the grid. So, from your perspective of building the models, how do you build it up and understand it and find the truth? Because I think what you and I found is the work that you did on the square grids, the intersect blocks that were right, left, up, down, instead of the Pittsburgh grid, which was underground, uphill, over mountains, and through various terrain, the algorithms became a different monster, and how to ensure accuracy became a different problem altogether. So, now where you are, I don't know, but I would love to hear more about how do you tie that model build with the physicalness of the grid and being able to, correct that accuracy.
All right.
Putting you on the spot. I'm putting you on the spot.
Right. All right. Should I answer the question?
Yeah, and be sure to introduce yourself too.
Right. Well, I'm very happy to be here. And I'm representing Power Energy Society AI Coordinating Committee. I'm the vice chair there. I'm also the chair for Big Data Analytics Subcommittee from PES. I want to report to you, in the past 2 years, actually, the PES president already started the AI initiative, and it's going to close this month. So what does that mean? That means they already had some roadmap. And what is the roadmap? The roadmap is to really go in for industrial question for AI. That's exactly what we were talking earlier today for the two presentations. And to respond to Elizabeth's question, I want to give you a story. So Arizona State has a power program. So we have students from all over United States. Many of them are very smart leaders. So we talk about the AI. And the question is maybe how to understand the trust from AI from academia perspective and from PS perspective. In the past 7 years, we organized, I don't know, maybe 100 webinars. Industrial people raise questions, academic professors answer those. Let me put it back 100 years ago. 100 years ago, let's say there's a salesman, or maybe there is just a man or lady on the street, and I suddenly tell her or tell him, I say, from today, I'm going to use this machine. It's called computer. She doesn't know that. He doesn't know that. I say, this machine is going to calculate your salary every month, and I'm going to give you that salary exactly as what is on this screen. At that time, that human may be nervous. What is that? Why should I trust that? So that is exactly the same thing that we are facing today. And now let's move 100 years later. Let's say 100 years later. If there's an AI, let's say human, let's say me, I make an error once every 100 days. And if it's already a common sense that the AI agents, for example, the Amazon, maybe AWS type of agents, they make an error once 1,000 days. Maybe I will say, oh, that's good. And if I repeatedly experience that for 100 times, let's say 10 years, maybe I will do the same. Oh, let's trust that. And that machine gives me the salary. That machine can maybe do the job. So that's how human need a trust to build up. So the next maybe question to conclude is how to build a trust. To me, there are 2 points. One is the time that I explained. It takes time for computer and the internet to penetrate all the way to the edge of the society. Yes, think about 20 years ago. Are we using cell phone computer as extensively as today? Yeah, let's think about 30 years ago. Are we using the internet as extensive as today? But today we are. So this AI is the same. So it needs time to penetrate, needs time for people to build trust. The second is structure. So we are living in a community. We have president, we have research principals, we have engineers, we have field engineers to report back. We trust such a structure to decompose and conquer. Each individual do the job defined by that role and finish that job on time. Why is that? Because that's what we can understand. Definition, target, procedure to finish it, milestone and deliverables. So that's we make it decompose and conquer piece by piece. But think about in the future. For example, I was learning from AWS. They already say they have 26 agents, right, talking to each other for Duke Energy. So in research perspective, we are building something similar. So one AI agent, let's say ChatGPT, it is talking to another AI agent, which is Claude. They talk to each other. I define the definition. You are the principal engineer. You are the field engineer for data. Talk to each other until you guys agree with each other. So we find many interesting discussions they have. We didn't experience the moment when Google say, oh, the two AIs doesn't talk in English. They don't talk in language. They create a new language. But I can tell you that is the structure that we can build up, like individual components, then you build a CEO. Maybe you think it's very hard, but that architecture can eventually make us to have the structural trust. In conclusion, what I believe is, number one, we are moving, so we need some pilot projects, use cases to understand better. And number two, we need a structure to know how we can trust them and they follow our human understanding. They may be smart, but they need to follow our understanding capability. And third, we need to define the roadmap stage by stage to mimic maybe what computer, internet showed to us the amazing story in the past. And I will answer more detailed question later. Thank you so much.
Thanks. And I think, this conversation can become quite philosophical very quickly because, one would say, what is trust? I mean, how I may trust the information you give to me may be very different than the trust that you and I have based on a previous experience. And maybe, that experience being good versus bad, right? So now we're talking about giving trust to these AI agents and then I don't know, 26 of them running in the background, at one point in time, how does the human become aware? So I guess you kind of mentioned the 2 a.m. call. So thinking about your previous operator experience, here you are sitting in your room and you noticed, the AI agent at the time gives you a call to make, what type of experience or, what would be your thought process to grow that trust to make that call?
Yeah, that's a great question.
Now you're.
Am I good? All right. Like someone said before, you gave these questions out ahead of time, but it's still very difficult to answer that question. In the operator world, we often go through simulations, right? So I think simulations is a great application for further AI application, for example, trying to come up with scenarios that you haven't seen or thought of, right? Sitting in that simulator world gives the operator that confidence to say, hey, this is what an emergency looks like. This is what that call looks like. If you've never seen it, never felt it, you're hesitant to deal with it. So for me, when it comes to critical infrastructure protection, so the bulk power system, our tools, our processes, they all have to work during an emergency, not just our daily routine, our daily life. Like the gentleman from Arizona Public Service said earlier, with all the dots on the board, in the end, the operator wants all those to be green or whatever color that was for good, right? We want our breakers to stay closed. And so that confidence, I think, gets built before the shift begins.
So I'm here is training. So, and I guess, when we think about the operations center, you have your state estimator, which this audience knows well. I thought it was fascinating as a system planning manager. My other role was to ensure the state estimator within the control room was solving, and not only solving, it was solving every 4 minutes against like 400,000 plus contingencies. So in effect, you know, operators already trust these enormous data sets churning an enormous amount of information. So the kind of the trust that needs to be gained is, like you said before, the shift. You're in maybe a simulator, or you're bringing in this new tool or this new agent or new capability to then be able to be in the room live and like accept it. So I guess it's really time. One needs to build trust.
State to, right? So, yeah, I like that analogy of the state estimator.
Yeah, this is open to all of you now.
Yeah, so it's reminded me, I like to tell stories. So I remember what at one point in time, this is, I don't know, 15 years, 16 years ago. And I remember operators like their SCADA measurement, right? They like to see the real-time measurement. But the real-time measurement is very expensive. So not all area have a real-time measurement. That's why we have state estimators. And I remember that if you have a state estimator solution and you have a measurements, which one do you think operators actually going to agree and like the most? They would trust their measurement, right? I remember at one point in time, an alarm comes in and it says that because you're basically saying, okay, I get a transformer that is state estimator showing that is overloaded, but I don't have real-time measurements for it. So you pick up the phone call and say, hey, this tool says that it's overloaded, but we don't have any way to verify it. So they send somebody, and because this is in the middle of nowhere, they send somebody, and 3 hours later, and they says, yep, it's been overloading for the past 4 hours. That to me is a very nice story to be able to tell people, look, your tool works, right? There's a situations where sometimes tool doesn't work, but as you keep adding and getting better data, your tool works. And I think this comes to the point where people are getting more and more trusting to your tools, the more success story that you heard. A lot of people did not trust PMU at one point in time because we were thinking PMU is a solution looking for a problem. And now in the Western Connection, at least in our shop, we use PMU quite a bit. We have oscillation detections, and we believe that yes, there is an actual oscillation, and we detected oscillation. Then the next questions become oscillation source locator. That's kind of like a new thing in the past few months now, where people try to figure out how do we locate that source of the oscillation for input sources. But now we get into a point where we start again, success story from one operator like to talk. So when the operators start talking about, hey, that happens in my shift, and it was cool. We were able to find the source locations, and we just pick up that phone call, and we told the battery and the solar, and it's like, if you don't get your stuff done in 5 minutes, I'm gonna disconnect you. They feel very powerful, right? And they did. They disconnected the resources until that everything came back. But that story, I think, like professors was talking about, that story of times and people being able to hear success story from one to the others, it's very helpful. Now, of course, there's all the bad story about how the bad data gets in, and then you get the wrong solutions. But I think for every success story that is being shared, being from people to people, it's the same thing. We're human.
Right. 3 positives to outweigh that 1 negative experience. That's how we're wired.
Yep. Well, probably more. But
Now,
you have to tell the story.
right. Share the stories.
Okay. So I want to add a few things to what previously said here. AI is a tool. AI is not a human. Some people felt back in 2023 that AI is a human. We're talking to a human. No, it's a tool. And then the other thing, this tool is to support decisions, but it's not the final decision maker. I know we're gonna cover who's accountable for those decisions in a minute, but the final decision maker is the operator, is the engineer, it's not the AI. The AI is just an auxiliary to help making the decision. And I think if we get to that point and that understanding is going to help all of us in this journey. And, talking about false positives, false negatives, we need to also keep in mind that we provide electricity to people, okay? People who have lives. We can provide electricity to hospitals. So the operators, they feel under pressure that they need to make the right decision. And I don't think we're anytime close to have an AI running the control room. My predictions, probably within 5 to 7 years, we're gonna probably see it, but not anytime soon because we're not there yet.
I'm going to throw this question to you, Dr. Wang. So, something else about how the industries ran right now, from the planning realm to the operation realm, is, we validate our plans, our projects, the performance of the grid on a very, this probabilistic type thought, right? And it's our industry is probabilistic. And what we run and how we set up our analyses is very deterministic. And then we a large amount of our decisions are made on this like n-1, losing one element. What happens and are you able to resurrect? So I guess, to your perspective, how do you validate going from a world where now we can probably swiftly move into running these analyses that we used to be very deterministic on in a probable state? I guess, like, how do you see that transition happening? And again, while building up that trust.
Right, that's an excellent question. I will use my class 360 on power system to explain. So for example, when I work with utilities, I have maybe 10 projects with utility directly, and I also work on 6 Department of Energy projects. So we had many issues. For example, measurements, right? People say 5% error from the old AMI, and now the new PMU, maybe 0.1% error. And then sometime people say, oh, they are bad data. Occasionally, I remember when I was in Pittsburgh, the PMU is half of the PMU is with bad data, more or less. When I say bad data, it's like maybe synchronization, not so good. As technology changes, now it's much better. And also sometimes when we get the data from the utility and when utility get our data, we find sometimes the data is not good. And maybe I should say not so loud, but garbage in, garbage out. So that's occasionally what we face. The algorithms may be good, but we do need somebody to guard us. So in conclusion, what I want to say is probabilistic understanding is already there. For us, when there are some probabilistic error, less than 5%, less than 1%, what did we do? We just say, okay, let's just run it, right? Just, as long as it's not too big, let's just move on. So now the AI is giving us maybe some probabilistic understanding. I think there are 2 parts that had a concern. Number one, is this probabilistic uncertainty the same way as the Gaussian noise or maybe the bad data from PMU or from communication error, right? Because that's what we can understand. And the second one is, what if AI is generative? Like, if it's giving us some uncertainty that we cannot quantify, what can we do? So from academia perspective, and based on maybe the webinars we host between academia professors and the industrial people, I think one thing that we can do is we try to narrow down, right? For example, one metric, probabilistically from the operator's perspective is 5%. From maybe the user perspective is 1%. So you try to maybe use many of these metrics to quantify. So in the end, maybe this is the law of large number. As you have more votes or more suggestions, the probabilistic quantile will be smaller and smaller until a point that human can trust. So that's what I can think of now.
So, just layman's terms. I mean, fundamentally, we do a lot of de-risking and really making decisions without knowing all of the answers in a very like vast space. So if we could reposition or rethink or reteach or re-educate or retrain, that the tools are really to reduce a lot of the air and the risk that we're already sitting with. And I think we don't speak to that vacuum enough. That, you know, like the tools that we have today, you know, are very accurate and have continued to keep this enormous reliability that we have. The use of these new tools really just helps drive a lot of that air out and really maybe that unknown.
Yeah, I want to add a little bit to that because that actually
I mean-
reminded me about our stuff with the what we call the BA capacity planning AI in there, right? So that was actually one of the hardest thing where we basically asked the questions, what is the likelihood of a balancing area would go to an energy emergency alert today and tomorrow? And it's simple questions, but it has so many variable in it because to be able to know whether you're going to be energy capacity is you need to have a load forecast. And the load forecast itself has sort of variability and certain uncertainty in there. And then on top of that, you have to figure out what is going to be your generation capacity. And the generation capacity, if it is just a gas unit and if it is just a firm dispatchable unit, is very simple. But then you add the solar forecast, the wind forecast, which we get really good at solar and wind forecast. What I started learning is actually you need to also add what is your hydro forecast. In the Western interconnection, we have a lot of hydro. And most of us, if you're not doing day in, day out of hydro forecast, you don't know what is actually the capacity of that hydro because there's so many things that goes wrong with, there's so many things that's put into that application in there, right? About irrigations, waters, and minimum run of cubic feet per second, and all those stuff. So we started learning that good data, garbage in, garbage out, again, plays in there. So we start asking the questions, okay, with all the BA that has hydro, for example, you never told me what that hydro is derated to. And they always say, well, there's nothing wrong with the generation. It's not derated, but I just have a different CFS requirement. Well, really, you cannot produce that energy then. Now you start recognizing that AI is telling you that, oh yeah, you have sufficient capacity because of the data that we're telling them that you have sufficient capacity. But the reality is you have to get AI to start learning about the water management to actually knows what the hydro is going to look like. So whose fault is it? Well, I don't know if it's anybody's fault. AI is a tool, right? And we have to actually allow AI to start learning about hydro profile based on water river. It's just getting crazy. Right. So I think to me, getting to this building the trust it has this garbage in, but also letting the people that use it know why it's giving what seems to be a crazy answer. And once you start realizing that, the AI is giving me crazy answers because the data that was in there is pretty crazy, which is not really realistic to begin with. I think a trust of why the AI telling you why it's doing helps the understanding of the user.
Right, and kind of like the video that you showed, the AI was helping to write the code, which then you have all of that data or information for future look back. And so there's even more transparency that's now becoming available to all end users, and it's kind of a full circle. It's something that we have just trusted based on, for instance, I remember running a power flow solution in California, and I kept not getting my flat lines. And in the end, I found a generator that was 5 states up, maybe 3, that like had a tweak of a value and it was wrong. And then once I changed that decimal, the whole solution solved. And I remember that just blew my mind because how much trust were we putting in all the other data that's sitting there unbeknownst to us? But with these tools, they can actually, extract all of those scrubs and bring that information to you rapidly to then go forth. And again, I think these are the topics that we need to talk more openly about in this vacuum. That you look, go ahead. You want to?
Yeah, I mean, and again, another thing from a change management perspective and training perspective is that you have to have a consistent messaging that those AI tools are not going to be replacing people, and it's going to help the business in their process. And I'm a big believer in like 5 minutes, 5 years. I don't think the AI would be able to the decision, give more insight. And they were speaking about I'm drawing blank. Explaining how the AI came up to that conclusion. This is great, but you need to start even before. You need to start when you have a problem and you need to build a solution to fix that problem. Throughout the process, you need to engage and involve the business users in this process. So when there's an outcome, they could easily interpret and understand those results.
We're bringing back system thinking into all elements of one's job and giving them tools to be a system. I think we just answered in a couple ways, but I would love to see if you guys felt the answer yourself. But when an AI informed decision goes said bad, where's the accountability sit? And I'm gonna kick that to you, Ryan, and then we can go down the line again.
I guess that
Since you're the one that holds people accountable.
that question kind of is framed like we're already using it to make our final decision. I don't think we're doing that yet. I think in the white paper, even though it's 2 years old now, I think about 50% of the folks in the survey said they're using it in some form, but they have a lot of guidelines around it. There is no standard around AI specific to NERC, but there are SIP protection, still having to follow the standards as written.
So the human is still accountable.
Correct.
Okay. Didi?
Yeah. Sure, the human. I think that's one of the things that we talked about actually in our company in the bigger AI portions in here, because we use the normal Copilot stuff like everybody else. So we actually have an AI governance and AI policy internal to California ISOs where first we actually requires everybody to train on AI. So we require for everybody's to have AI literacy, so they know what AI does, what the machine learning is, what a RAG is, what an agent is, what a hallucination is, right? So we actually train everybody to know in there, and then we said that okay, now that you are in there, you could use Copilot for California ISO's purposes, and only Copilot, and then same thing that we use WebEx, right? And WebEx have an AI summary functions in there. You could use WebEx and you could use AI summary functions in there. The same thing in the system operations, we have this specific AI. So, but at the end of the day, the policy that we basically share with people that you're responsible for what you're doing because it is just a tool. Somebody mentioned this today. AI is involved, but not in control of everything. So you're still responsible and in control of what you do, what you have to do. And I think making sure that is understandable. It's actually also helping them to understand that in that context, you're not going to be replaced with an AI. your job is secure because you are still the one that is responsible for that. So that's basically how we approach that.
Yeah, the ultimate accountability is under the decision maker. So if we have an operator in a control room, he needs or she needs to have full accountability on the decision, on the final decision. Again, if we train operators on how the AI is built and there's a space for error, then, you know, with their expertise, seeing the outcome from the AI, they would probably make a better decision. And if their decision is different than the AI, then, you know, start asking others, you know, until verify the accuracy of the answer from the AI. But again, at the end of the day, the decision maker is.
So humans still need humans.
Yes, human in the loop. And I think that's going to come up at some point as a standard from NERC to have a human in the loop in any of these processes.
Dr. Wang?
All right, I agree. I think it's human. I want to bring a terminology. So in state estimation, power flow analysis, when we learn, we say, who is accountable? Who is important? Who is critical? So we typically say the voltage. So what is voltage? Voltage is the minimum set of variables that can recover all the measurements in the system. So there are two keywords. One is minima. The other is fully recoverable. It's like one-to-many mapping, not many to one. So now, when we talk about who is accountable in the utility, I can think about it in the following way, right? Whoever is the minimum set of human decision makers in the control room, in the metering department, in maybe the planning department, right? The minimum set of human managers who make the decision, who trust, we say, do it. So they are accountable. And the second part I want to ask is, think about it. When we say who is accountable, should we ask, why do we really need such an accountability or the trust in day one? Right? For example, I think my daughter trusts me very much to manage maybe the appliances in the home. She never asked me to say, hey, daddy, explain how this works. Daddy, how does that circuit look like? Maybe on a computer, right? So that is maybe what we need to look forward in the roadmap. We need to define who is accountable, like the minimum set, so that we focus more resources in those strategical locations in the utility. So those are my answers.
So, yeah, go ahead.
So what's funny about this is every time I think about this, every time I think about major blackout, we always blame it on tools.
Right.
We never blame it on the people.
I know what's going to happen. What is happening?
Right? So there remember the three T's that we always blame any major blackout: tools, training, and trees, right? We always do. We never blame it on the people.
Yeah, what are we afraid of?
Well, exactly. So when we start talking about AI, I think we talked about the accountability is always the people, but when we talk about state estimators, real-time continuous analysis, voltage stability analysis, now we've never actually blamed it on the people. We always blame it on the tool. What do you think about that?
I think you are spot on, and you nailed my question. No, I agree. And like just something, I don't know why this popped in, but we have forever accepted the fact that we plan our grid on peak. And we're in a world that we're resisting and fighting, knowing that we can start to plan our grids on this flexible, non-peak pursuance because these tools are now becoming available if we get out of our own way and start to accept the training, the capability, the accessibility of the data. And I just say, we went from running system planning analyses, by the standards to do a winter peak and a summer peak, and you run your 400,000 contingencies against those two moments in time. And what AI, aka these agents and these structures, aka technology tools, can really produce is now, 1 billion scenarios on enormous amount of time stamps and give us Wouldn't it be amazing? The same answers that we already get today. But, you know, there's that trust being built. But I think we have to get our own way that like these tools can really open the door and give us an opportunity to study the systems differently. Because in the end, yeah, we're gonna blame the tools.
I want to give an example here, not relevant to utilities.
And then if any questions start lining up.
Yep, not relevant to utilities. So I have a garden. I have 40 fruit trees. So I use the AI to ask it about